please have your notebook open to the blank page for us to take notes on and write down this topic, how changes in M and B affect the graph of a line, which is what we looked at on Friday. And just a reminder, M means slope and B means the y-intercept. And we're going to summarize how, if we change the slope or if we change the y-intercept, what that would do to the line. So I'm going to show you a summary to write down, and I want you to pause the video after I show it and write down everything in it, and then I will explain what I mean by everything. So here's the summary. Please pause the video now and write this all down. Okay, I hope you have that written down. So in summary, the line with the higher absolute value of M is steeper. What that means is, when it says absolute value, we are just going to ignore the negatives. Because the negative really is just telling us what direction the line is going. The steepness is told by the number without the negative, and that's what absolute value means, really. So an example, if we had a line whose slope was -5 versus a line whose slope was +3, the line with -5 slope would be steeper. We ignore the negative. 5 is a higher number than 3, so this would be the steeper line. If the slope changes signs, the line switches directions. So just if it goes from positive to negative or negative to positive, it's going to switch which way, if it's rising or falling. And then if B changes, or if the y-intercept is changing, it shifts the line up or down. And when you're asked to describe how it changes, you have to be very specific about how many units and what direction it's going, up or down. All right, we're going to just look at some quick examples. So example number 1, it says compare the graphs g of x equals 6x minus 1 and h of x equals 6x plus 5. Please write those functions both down so that you have them in your notes. And when it says compare, I like to say what they have in common and what is different. And it'd be best if you can picture what these look like. Let's do a quick sketch. I'm not going to do like a perfect graph, but g of x, it begins at -1 on the y-axis, so I'm just going to make a point and assume that's -1. And then its slope is 6, which means up 6 over 1. So it's going to be going up 6 over 1. I'm just going to say it's about like that. Rough sketch. So that's g of x. H of x begins at 5 on the y-axis, so let's say that's about right there. And it also has a slope of 6, so it's going to go up 6 over 1, or I can go down 6 to the left 1. So it's going to be about like that. That's h of x. Oh, maybe it would help if I did different colors, sorry. Okay, so really these two graphs, what they have in common is they have the same slope and the same steepness. So we could say h of x and g of x both have a slope of 6, so they have the same steepness. Sorry, my handwriting is bad. I'm trying to go fast. Okay, so that's what they have in common, and then we want to say what is different about them. And the difference is what their y-intercept is, and the way we talk about that is that g of x, if I just shifted it up 6 units, it would actually land right on h of x. So we could say h of x is g of x shifted up 6 units. So I have the direction and I have the number of units. And you could actually see, since I have a smartboard, I can take my g of x line and move it around. I could just, if I didn't label all my units, but it's really going up 6, and then it would land right on top there. And we know that it's 6 apart because if you compare the y-intercepts, it's going from -1 up to 5. These are 6 apart. Okay, so that's one example. Let's look at one more example. And it's hidden under here somewhere. There it is. Number 2, so write this down. M of x equals negative 2x plus 2. N of x equals 1/4 x plus 2. So I'm going to do a quick sketch. M of x is starting at positive 2, so let's say that's like right here. And you can make a nice graph since you guys should be doing this on graph paper, so you can make one better than mine. So anyway, starts at 0, 2, and it's going down 2 to the right 1. I'm going to say something like that. That is M of x. And then I'll do N of x in red. N of x is beginning at 2, also 0, 2, and it's going up 1 to the right 4. So it's going to be more like this. And that's N of x. Okay, so when I compare them, I want to say what they have in common and what's different. Maybe they won't always have something in common. In this case, they do have something in common. Both M and x and N of x have a y-intercept at 0, 2. So that's what they have in common. But then for what's different is their slope and their direction. So we could say, but M of x is negative, and it is steeper. So M of x is negative and steeper than N of x, which is positive. And I know that M of x is steeper because negative 2, if I ignore the negative, 2 is a bigger number. It's greater than 1/4. And so, therefore, it is steeper because we're just looking at the absolute value of those numbers. All right, so hopefully that makes sense to you and goes along with what you saw in class. So that's the end of part 1 of this video. Now for part 2, go to that handout that you taped into your notes. It looks like this. It's about parallel lines and perpendicular lines. And we're going to summarize some things about the slopes of those types of lines. So parallel lines are lines that never intersect. The following 2 graphs show examples of parallel lines. I know on the handout it's really hard to read the points for some of these anyway, so let's label them together. So on the first one, line A, it has a point. Its y-intercept is at 0, 2, and it has another point at 4, 4. And we want to find its slope, so it is going up 2 from 2 to 4 and over 4. So up 2 over 4, 2 over 4, and we always reduce, so that reduces to 1 over 2. Slope of B has a point at 0, negative 6, and it has another point at 4, negative 4, right here. So label your points on your paper, and then to find its slope, I'm going to do the rise over the run. From negative 6 up to negative 4, it's going up 2, and it's going to the right from 0 to 4 over 4. So it's also 2 over 4, which reduces to 1/2. So how do the slopes of A and B compare? We could say they are the same. If I had chosen other points, they might not have looked the same, but if you reduce, then they are the same. So we can maybe add they are the same in parentheses when reduced. Okay. For the next example, slope of C, let's find 2 points on C. So there's a nice one at the y-intercept, which is 0, 100. And then there's another one down here. This is called the x-intercept, and it's at the point 5, 0. So if I draw in a slope triangle to show the rise over the run, from 100 down to 0, it's going down 100, and it's going over from 0 to 5, 5. So my slope of C is negative 100 over 5, which reduces to negative 20. And then if I find the slope for line D, I've got a point. It's a little harder to see on this one. There's a point here at 0, 45. And then there's a point at 125. Okay, so if I'm going to draw a little slope triangle. It's going down from 45 to 25, It's going down 20. It's going over from 0 to 1 over 1. So negative 20 over 1, which is also the same as just negative 20. So how do the slopes of C and D compare? They are the same when we reduce. All right, so fill in the statement about parallel lines. Parallel lines have the same slope. That should make sense because parallel lines have the exact same steepness. That's why they never cross. And if they have the same steepness, they have to have the same slope. Perpendicular lines are different. Perpendicular lines do cross. They cross or intersect at a 90-degree angle. The following two graphs show examples of perpendicular lines. Okay, so let's find the slope of A. It's got a nice point at 0, 0, also known as the origin. And it's got a point at 4, negative 6, down here. Okay, the slope of that, it's going down from 0 down to negative 6, so down 6. And from 0 over to 4, it's going to the right 4. So negative 6 over 4 reduces to negative 3 over 2. And then slope of B, I have a point at 0, negative 4. And then another point at 6, 0. So that is going up from negative 4 up to 0. It's going up 4. And from 0 over to 6, going over 6. So it was positive 4 over 6. And that reduces to 2 over 3. So how do the slopes of A and B compare in each of the above graphs? So we have a negative 3 halves and a 2/3. So negative 3 halves and a positive 2/3. So see how, well, it makes sense that one of them's positive and one of them's negative because this line is negative, it's falling. This line is positive, it's rising. So they're opposites because one is positive and one is negative. So we could say opposite signs, I guess that's what that is. And then also, it's like a 3 on top in one and then a 3 on the bottom in the other, and then the 2's flip. And so maybe we could say something about how the fraction is flipped. Okay, let's see if the same thing happens in the other pair of graphs. So on this slope A, I have a point at 0, 15. And then another point at, it's pretty hard to see, it is at negative 5, 12 is the one I'm going to use. Negative 5, 12. Okay, so my rise over my run, it's going from 12 up to 15. That's going up 3. And then from negative 5 over to 0, it's going over 5. So up 3 over 5. That does not reduce, so I leave it like that. Okay, slope of B, I have a point at 0, 2. And another point at negative 3, 7. Right there. So this one is a negative slope. So it's going down from 7 down to 2. It's going down 5. It's going from negative 3 over to 0. It's going over 3. So negative 5 over 3. So let's compare those two. 3/5 and negative 5/3. So they do have opposite signs. This one's positive, this one's negative. So that pattern holds true. And the fraction is flipped again. The 3/5 turned into a 5/3 for the other one. So it seems like from these two examples anyway, seems like we found this pattern. And so let's fill in the statement at the bottom. Perpendicular lines have, we're going to call it opposite, because one is always positive, one is always negative. And then the thing about the fractions being flipped, there's a fancy math word for that. I don't know if you've heard it before. They're called reciprocals. So perpendicular lines have opposite reciprocal slopes. So one other note about that, just because it's usually confusing for some people, if you had a line whose slope was 2, And you wanted to know what the slope of the line perpendicular to it would be? It would be negative, I should say a perpendicular line would have m of, it has to be negative if, because the 2 is positive, and if to flip a 2 upside down, you have to pretend it's 2 over 1, and so it would become 1 over 2. Okay, I think that's about enough for now, so thank you, and I will see you guys Monday.